Decision table is also part of specification based or black box or behavioral testing technique, and which are part of dynamic design technique. So in this technique, okay, so the technique of equivalence partitioning and boundary value analysis are often applied to specific situations or inputs. Okay, so if you take equivalence, partitioning or boundary value analysis, which will be applied to a particular input range, right? Let's say if we are having a set of inputs. Okay, for example, if you are only working for email, you can apply equivalence partitioning and boundary value analysis. Okay, so if there is a password also, so if you have to test email and password together, okay, so boundary value analysis or equivalence partitioning are not a right choice for that. Okay, so when you want to test multiple fields together, when you want to test multiple input ranges or multiple fields together, so equivalence partitioning and boundary value analysis are not the right choice. Okay, so this is where the decision table came into picture. Okay, so this equivalence partitioning and boundary value analysis, you can apply to a particular specified field. Okay, you can able to apply to a specified field. Okay, each field will be having set of range, right? So for example, if you take age, it will be having 18 to 100. Okay, so there you can apply an equivalence partitioning and boundary value analysis. So that's well and good. But if you want to test multiple input fields together, then decision table is the right choice. Okay, remember. So you have to remember here, equivalence partitioning and boundary value analysis are suitable for a single input field or a specific situation, whereas decision table is very much used and very much important to use when multiple fields are required to test together. Okay, that's about decision table. Okay, for example, let's take an example. So we are talking about decision table, right? Let's say I'm having a email and I'm having a password. Okay, so I can apply a email, yes or no? I can apply a email. Okay, I can also apply a password. Okay, and the expected output is, okay, expected is should allow to log in. Okay, allow to log in. So if I don't apply email and if I don't apply password, should not allow, right? Should not allow to log in, am I right? Next, I apply email but I don't apply password, and I don't apply no, I don't apply email but I apply password. Okay, and let's talk about, in this case it should not allow, in this case also it should not allow. Okay, so finally, how many test cases we got? So that can be defined as you know number of conditions for input 1 and number of conditions for input 2. Okay, for the input 1, the number of conditions are yes or no, that is 2. Okay, and for input 2, that is password, the number of conditions are yes or no, again 2. Okay, so total 4. So let's discuss about one more example. Let's take the same thing. So you are having a email and you are having a password. Okay, now so there are different other conditions I'm applying. So I'm applying email as blank and password as blank, and in that case a error should be displayed, please enter email or password, whatever it is. Okay, now the other one is email as blank and password as, I'm applying password with invalid input. Okay, that's one thing. So email is blank and password is valid. Even in this case also, it should be failed. And email as invalid, password as blank. Email as invalid, password as also invalid, and like this. Okay, here it is invalid and here it is valid. And valid, blank, valid, invalid, and finally valid. Both are valid. I'm applying email as valid and password as valid, and finally I should see a home page. Okay, otherwise I should see only login page, right? So in this case, if you see, the number of conditions for input 1 is blank, invalid, and valid, that is 3. Okay, that is 3. And for the password, so it is also again blank, invalid, valid, that is 3. 3 into 3 equal to 9 set of test cases you can get it. So let's talk about another example. Okay, so there is a library system and a person wants to take a book from the library. So if he wants to take a book, there are 3 conditions are verified. One is that person is already registered. Okay, if he is registered, then there are 2 more conditions will be verified. One is, so is that person having any outstanding fee? Okay, is that person has to pay any due amount? Okay, or he already exceeded the borrow limit? Let's say the borrow limit is 4 books. He can able to take up to 4 books. So he already taking the 4 books and he is trying to take another book. Will it allow? The system will reject him. Okay, the person will reject him. Whoever wants to give the book, he will reject him. Okay, so here if you can see it. Okay, so consider F is some problem. Okay, you can say it is not. So user registered, false, means he is not registered. Okay, and so so I'm considering as some outstanding fees as false, and borrow limit also false. So in this case, can he able to borrow a book? No. Okay, and he is not registered, and doesn't matter whether he is having a juice or under the borrow limit, whatever it is, it's a no. So in this way, I'm considering all these inputs. Okay, so for example, user has registered, but he has false means some problem, right? He has some outstanding fee, and he also taken he also crossed the borrow limit. So finally, he'll be no. So user has registered and he has some outstanding amount, but he is under the borrow limit. So even though he can't get the book, so he is registered and he doesn't have any outstanding fees to pay, but he has crossed the borrow limit. So no. So he is registered and there is no outstanding fees and he is under the borrow limit. Okay, that means so he has just taken below the 4 books, then he can able to take the book. Now here you can see, so for the input 1 there are 2 conditions, false, true. Okay, for the input 2 there are 2 conditions, false, true. For the input 3 there are 2 conditions, false, true. Okay, 2 into 2 into 2 equal to 8. So you can able to write 1 2 3 4 5 6 7 8 test cases. Okay, so we can also able to optimize this table. Okay, we can also optimize this table and get less number of test cases than 8. Let's see that. Consider this example. So user is registered, he is not registered. So is it matter, is it matter about number of the outstanding fee or under the borrow limit? These two fields are doesn't matter. The person itself is not registered, then why do we look into outstanding fee and under the borrow limit? Okay, if he doesn't register, he doesn't have any information about these two things. Okay, so in this case, if the user is not registered, let's go with no. Okay, so you will not get the book. And user is registered and he is having the outstanding fee. Okay, so if he is having the outstanding fee, here itself we can say he is not eligible for the book. Does we require to look into under the borrow limit? That's not required. It doesn't matter whether he is under the borrow limit or he already crossed the borrow limit. It doesn't matter. Okay, because so in the outstanding fee itself he is having some due, and here itself he failed to get the book. Okay, so let's say user is registered and he doesn't have any outstanding fee, and he is under no, he crossed the borrow limit. Again, it's no. Now user is registered and he paid all the outstanding fees and he is under the borrow limit, and yes, he will get the book. So that's about decision table. Okay, so hope you guys understand about it.